we started out with watching The Price is Right, and we looked at the range game. And confidence intervals are essentially that red interval that stopped it. And if the population mean or the thing that you're interested in is inside the red thing, then you win. And if it landed outside, then you lost, right? So we did The Price is Right. We talked about how to create confidence intervals. Remember, we have all these symbols. If you ever get confused, you can look back and see what those are. Okay. And then we had specific words like standard error and margin of error and all those weird things that all combine together to create our interval. Okay, so before we go on, let's just kind of go through the process of this. You don't have to write this down. We're just trying to jog your memory here. But when we're finding confidence intervals, there's kind of a step-by-step process, right? The first of it, which is creating our assumptions, right? So what were the two assumptions we had to look for confidence intervals? Good, this is given to us, right? Oh, I'm just writing like right below the procedure one. You don't have to write it down if you don't want to, but we're right here. All right. Can someone give me another assumption that we had to do? Yeah. Good, n is bigger than 30, right? We would look at the sample size n and see if it's bigger than 30. If it wasn't bigger than 30, we could also look into the question and be like, is the population normal, right? So, or the population is normal. Okay, so we had two assumptions. One of them doesn't really make sense yet, but I think as we'll go further, it'll make a little bit more sense. The second one is that the sample size is bigger than 30 for the population. Okay. Next, we had these things called critical values. How did we find these guys? Yeah, we looked at the chart, right? Okay, then we had this thing called standard error. Anyone remember the formula for standard error? Good, standard deviation over the square root of n for the sample size. Okay, so that's something that you have to memorize. Finally, margin of error. How did we find this one? Give you a hint, you have to multiply two things. Good, we multiply the critical value times the standard error. So I think we're pretty good with going through these steps. It's kind of just putting them all together now. So once we find our confidence interval, we would take our point estimate, or x bar, and add and subtract the margin of error. And we would interpret our interval by saying we are 20% confident that the population mean is between whatever two values, right? Okay. We did an example of this where we put everything together. Did we do example 5? Yeah, we did. Okay, cool. So we did example 5. So you're all very confident with doing these types of questions, right? Our quiz will be very similar to something like this. I know it seems like a lot, but I think it will help us prepare for the test. Okay, so going on. Let's see. Figure this out. Okay, so we talked about margin of error, and let's just try to look at this more conceptually now. I think we're all good on how to find it, but let's try to see how this relates to like the size of the interval. Okay, so we talked about in the very beginning when we brought up confidence intervals that the larger the margin of error is, or the larger the interval is, the less meaningful winning the game becomes, right? If the interval was really big and we won, well, anyone could have won, right? If the margin of error is really small, it becomes less meaningful, right? It becomes harder to win the game, okay? So first of all, I'm gonna just kind of show you how margin of error relates to the size. Okay, so we know that the margin of error, let me just make up some numbers. I'm not, this isn't found in any sort of way,
let's say the sample mean was 20 and the margin of error was like 2. The margin of error is the thing that we add and subtract to the interval. Okay, so keep with me here. Okay, let's say I had an interval that looked like this, the sample means in the middle, and the margin of error was like 2,000. Really big margin of error. I'm going to draw another one. Let me compare that to something that has a margin of error of like 0.0001. Would this interval be wider or would it be smaller? Oh, yeah, smaller. Smaller, right? Because we're adding and subtracting something a lot smaller from the sample mean, right? So this one would look like that, right? So whenever I talk about the size of the interval, I could talk about it in terms of like how wide or narrow the interval is, or I could talk about like the margin of error being big or small, right? That's the same thing. Like they mean the same thing. Margin of error being big interval, margin of error being small, small. Okay. Are we all good with this? All right, let's go down here. Now, let's talk about how the size of the interval or the margin of error is affected by two things, okay? One, the confidence level. Remember, confidence level is like 95%, 80%, 20%. We're also going to talk about how it relates to the sample size. How big or small is our sample? Let's start with confidence level, okay? The margin of error has a direct relationship with confidence level. Let me explain what that means, okay? Okay, so the confidence level, remember, is like 95%, your 80%, your 20%, things like that, okay? So as the confidence level increases, what do you think happens to the margin of error if it has a direct relationship? It increases, right? Margin or direct relationship means as something increases, the other thing does the same thing, so it increases. So the margin of error will increase. Okay. What do you think happens when we decrease confidence level? Margin of error will decrease. Good. Okay, so basically, whatever the confidence level does, the margin of error or the size of the interval will do the same thing. Any questions so far? Okay. Let's go over here to sample size. So, unlike confidence level, sample size has an inverse relationship with margin of error. Okay, so let me rewrite this as the confidence level increases. Okay. As the confidence level, oh, sorry, I didn't mean that. I meant the sample size, sorry. I'll give you a moment to fix that. Okay, so we're talking about sample size and how big or small the interval is. As the sample size increases, what happens to the margin of error? Decrease, right? Inverse relationship means they do the opposites. When you inverse something or you invert, you're reversing it, you're turning it upside down, you are doing the opposite. Okay. So as sample size decreases, margin of error will increase. Any questions so far? Cool. All right. Now we can apply this in certain examples, right? Let's just say we have a guy named Greg. He makes a confidence interval using a sample size or sample of size 30. So here we're talking about sample size, right? Okay. So then he makes another confidence interval, but now the sample size is 100. Okay. So the thing that's changing here is the sample size, right? And what did it do in this question? Did it increase or did it decrease? It went up, right? It went from 30 to 100. So this definitely increased. It went from 30 to 100. Now you might think I'm kind of stupid for writing this all out, but I promise you, sometimes I make mistakes when I don't write things out. So I'm just going to show you how I do it. And if you can do this in your head. Okay, so sample size. Let's look back up here. Well, it says sample size has an inverse relationship with margin of error. Okay, so if the sample size increases, what happens to the margin of error? Sorry, I didn't hear. Decreases, right? It does the opposite. Good. Okay. Now the question didn't talk about the margin of error. It's talking about the confidence interval, but we know that the margin of error is kind of like the same thing as the size of the confidence interval. So if the margin of error decreases, do you think the interval is going to get smaller or bigger? Smaller, right? The margin of error is what we add and subtract. So if we add and subtract something really small, well, it's going to get smaller. Okay. So to do this question, first we had to identify what actually changed, which was the sample size. We think about what the relationship is, and then that kind of tells us if we're decreasing or increasing. Any questions on example 6? All right, take a look at example 7. I'll give you a few minutes to work on this one, and then we'll come back together. All right, so now we have Regina. She makes a confidence interval using a confidence level of 95%. So we're talking about the confidence level, and then she increases the confidence level to 98%. So the thing that's changing here is the confidence level, and it definitely increased, right? From 95 to 98, right? Okay. So since the confidence level increased, that means the margin of error, well, did it increase or decrease? Increase, good. And since what we're adding and subtracting is getting bigger, of course, the interval is going to be bigger. So bigger. Okay, if you can do this in your head, I'm not going to require you to write this all down. But for some reason, it's easier for me to write all the steps down. I don't make a lot of mistakes during using this way, so I find this one to work for me. Okay. Any questions on like the relationships between the two, getting bigger, getting smaller, anything like that? All right. Last thing on confidence intervals. Okay. So we've talked about how things relate to the size of the interval. Okay. And sometimes what we want is maybe we want to set up a situation where we're guaranteed to have a small enough interval. Okay, small intervals are good, right? That means it's harder to win the game. It means a lot. It's a lot more meaningful to us. Okay, so maybe we don't want to like just leave it up to chance and see how big the interval is. Maybe we just want the margin of error to be 10. Okay, so I was like, you know what? I'm going to set up a situation. I'm going to design my experiment around the fact that I want my interval to be this big. Okay. The big question here is, well, how big of a sample do I need to collect? Remember, sample size has a relationship with the margin of error. If we have a big sample size, then we're going to have a smaller margin of error. Okay, so this question, or these types of questions, are going to give us a situation where we want to find how big we should make a sample to make a certain margin. Okay, so let's make M be the margin of error. That's pretty easy, right? M for margin of error. We're interested in making this margin of error, and we want to find the smallest sample that we need to get this margin of error. Okay, the sample size that we need is going to be the critical value times the population standard deviation all over the margin of error, all to the second power. Okay. Now, I do want you to memorize this. Okay. It's not too bad of a formula, right? The margin of error is on the bottom, critical value, population standard deviation on top. Okay. But before we get into a question, there is something very important about doing these types of questions, okay? Let's say we do this question and we get a sample size, but it ends up being a decimal, okay? For example, it ends up being 2.34. That would mean that the minimum sample size to get a margin of error of like 10 or 15 or something like that is 2.34. Now, unfortunately, when we take samples of things, usually like children, bunnies, people, something like that, we can't have 2.34 of a human or a bunny or a dog or something like that. So since this is the minimum, we want to find the minimum size to achieve this margin of error. The guideline for this is we're going to always round up, okay? We're going to round up. So if my answer was 2.34, what would this number round up to? 3, good. Okay, even though 3 is less than 5, we would still round this number up because we're trying to find the minimum sample size needed for something, okay? So even though we only technically need 2.5 dogs, we would still round it up to 3 dogs. Any questions before we do an example? All right. Here's an example. We have scientists and they want to estimate the mean weight of mice after they've been fed this special diet. That sounds actually really neat. So from previous studies, it's known that the weight is normally distributed with a standard deviation of 3 grams. We want to know how many mice must be weighed so that a 95% confidence interval has a margin of error of 0.5 grams. So we're looking at the smallest sample size. We know our formula has, well, the critical value, the population standard deviation, and M. We all know that this goes into these types of questions, right? Okay. What's M in this question? Good, 0.5. It's the margin of error, right? What's the standard deviation? 3, good. What's the critical value? Yeah, all right, awesome. How did you find 1.960? The chart, right? So we weren't given the critical value in this question, but we could use the fact that we want a 95% confidence interval and the chart to figure this out. Any questions so far? All right, so just using the formula we have to memorize, we're going to take n equals the critical value, 1.960, times the standard deviation, 3, over m 0.5 and square it. Okay. Now, if you are a little bit more technologically advanced than I am, you can definitely do this all at once in your calculator. I'm going to take this step by step. I'm going to do the multiplication first in the numerator to get 5.88 over 0.5 squared. I'm going to do the division to get 11.76 squared. And then I'm going to square it to get 138.298. Are we done? Are we done the question? Yeah, you have to round up. So what number does this round up to? 139, right? Even though the decimal is 2, we're still going to round it up to 139. Okay. Any questions on this one? All right. How about this? Try example 9. We will go over how to do this very quickly. All right, let's come back up to the front. I got Alyssa to write up her answer. Do you kind of want to take us through what you did? Mm-hmm. Awesome job. Any questions on example 9? All right. So that ends up section 8.1. We spent a lot of time on this one, but it was a very long packet, so that's probably why. So what we're gonna do is we're not gonna start a next section yet because, well, we have a quiz review and I didn't print out the packet. So how about this? The quiz is going to be something very much like the examples that we've done before with all the different steps. I know it seems a little bit long, but I think we have the skills to do it.